Good morning, class. This is Mr. Delamorte. I am going to go through topic 6.10, integrating with long division and completing the square today. Two very specific types of problems. I wouldn't say they're very common, but we'll go through them briefly to make sure you understand everything you need to know. Okay? So I wanted to practice both long division and synthetic division. Remind you of those two techniques. And then how we can integrate. So with the way that this is written, it's kind of a hot mess. The top doesn't really factor, and we need to try to get this to an expression. So what I can do is I can take that denominator. Okay, I'm going to take that x minus 2. I'm going to set it equal to 0, and I know that a 0 for this function, if it's a factor, would be 2. So I can synthetically divide this by 2. On the outside. Okay, and I'm going to list out all my coefficients. So 3, -1, -5, +1. And if you remember anything about synthetic division, I drop the 3. 2 times 3 is 6. Add going down. 2 times 5 is 10. Add going down. 2 times 5 is 10 again. Add going down. So now remember that this number at the end is my remainder. Okay, so if I wanted to write this now, we divided by a linear term, so it's going to go down by a full degree. So my new integral, change colors here, is going to be 3x squared plus 5x plus 5 plus 11 over the x minus 2. And we are going to integrate this. And now if you notice that most of this is just a polynomial, we just have that remainder that's left. So if I integrate this, the antiderivative of 3x squared will be x to the third, right? Reciprocal in front. 5x squared, I'm going to get 5 times a 1/2 x squared plus 5x plus, and we're going to take a look at this integral a little bit more closely. Okay, so if I simplify what's left, I have x to the third plus 5 over 2x squared plus 5x plus now this integral. Now, if I were to show all my work here, I would do a u substitution. So if I let u equal x minus 2, then du is 1 dx, or dx equals du, right? So I can do plus the integral of 11 over u times, and dx is equivalent to a du. So I'm going to get an answer of x to the third plus 5/2 x squared plus 5x plus 11 times the natural log of the absolute value of x minus 2, because that was my u value, plus c. Okay, my natural log and my 11 look very similar, so I'm going to put parentheses around the 11. And this would be my antiderivative. So ultimately, when we had a big scary rational function and it didn't factor, or we couldn't break it down, then ultimately we can just divide it. Most of your result will be a polynomial, and then you can just integrate that polynomial. Okay. Let's try number 2. Number 2, I want to kind of review another method of division. I want to do long division. So I want to show you what that looks like in case you forgot. So on the inside, I'm going to write the numerator, x to the third plus x squared plus 2x. And on the outside, I have a 3x minus 5. Okay. Now, if I go about this, what's going to happen is I need to multiply 3x by a 2x to the third in order to make it a 6x to the fourth. Now, but you can't just do it to the first term. You have to do it to both. So 2x to the third times -5 would be a -10x to the third. And then this is the part where we make mistakes. We need to subtract. So 6 minus 6 is 0. -7 minus a -10 would be a positive 3x to the third. Then I'm going to bring down the next term. Okay, so what do we have to multiply 3x by to get 3x to the third? Well, we need 2 more x's, so x squared. So I have a 3x to the third minus 5x squared. I'm going to subtract 3 minus 3 cancel. 1 minus negative 5 is a positive 6x squared. Bring down the 2x. So I now need to multiply by a 2x. That gives me a 6x squared minus 10x. Subtract. 6 minus 6 is 0. 2 minus a negative 10 is a 12x. I am going to add a 0 because I can divide one more time. And if I multiply by a 4, that gives me a 12x minus 20. Subtract, I get 20 as a remainder. So what I'm going to do now is I'm going to integrate 2x to the third plus x squared plus 2x plus 4 plus a 20 over 3x minus 5. And don't forget your dx at the end. Okay, so now if I just take the antiderivative of each of these pieces, I'm going to get x to the fourth. If I do the reciprocal times 2, that would give me a 1/2 x to the fourth plus a 1/3 x to the third plus an x squared, because when I raise it, do the reciprocal times 2, that would just be 1, right? Plus a 4x plus, now I have this 20 times the antiderivative of 3x minus 5, 1 over 3x minus 5 dx, right? So I'm going to have to do another little u substitution there. So let me change colors. So if I let u equal 3x minus 5, du is 3 dx, or a 1/3 du equals dx. So I'm going to get an answer of plus 1/3 x cubed plus x squared plus 4x plus 20 times, this would be a 1/3 times 1 over u, right? So that's what I'm integrating. So if I take the antiderivative of that, I get a 1/3 natural log of u, right? And then I would plug that u back in. So I'm running out of room, so I'm going to actually erase. And u was a 3x plus 5, so I'm going to say 3x minus 5. And that would be my answer, plus c, of course. Okay? So we can integrate a rational function with long division and with synthetic division. So it's just a reminder of those two skills. And then completing the square. So I don't know if you remember how to complete the square, but we'll go through it here. So what I have is I have an integral of 1 over this quadratic, but I want that quadratic to be a perfect square trinomial. So what I'm going to do is I'm going to deconstruct that 10. I'm going to say plus 9 plus 1. Now you're probably wondering why I did that. The reason I did that is because x squared plus 6x plus 9 is a perfect square trinomial. It's just x plus 3 squared. And then I have this plus 1 on bottom. Okay? So now what I'm going to do is I'm going to let u equal the x plus 3. So then du would be a 1 dx. And I get just du equals dx. So now I have 1 over u squared plus 1 du. And I don't know if you remember this, but that would be tangent inverse of my u, x plus 3 plus c. So that would be my answer. Okay, so let's try to do it one more time. So if we take a look at number 4, now we have that negative inside the radical, like that. So I'm going to write this as a negative times x squared minus 8x plus 15. Okay, and I want to try to write a perfect square trinomial. So I'm going to do 1 over a negative x squared minus 8x. And in order to have an 8x in the middle, my perfect square trinomial would be a plus 16. So if you notice, these aren't equivalent right now. Right now I have an extra negative in the denominator. I have a negative 1, so I need to add 1. All right. So now if you were to distribute, okay, and combine like terms, you would get to the same. They would be equivalent statements. So I now have a negative square root of a negative, and this would be x minus 4 squared plus 1 dx. And now I can let u equal the x minus 4, which means du is a 1 dx, and dx equals du, right? So I'm going to have the integral of 1 over a negative u squared plus 1. And that's all inside the square root. If I write that a little different, you might recognize it. Square root of 1 minus u squared du, which is sine inverse, right, of x minus 4 plus c. So that would be my answer. Okay, so these are 2 examples of completing the square. Typically, when I complete the square, it will be something that will be inverse trig. And then when I do long division or synthetic division, you're going to have some natural logs in your answer. That's pretty standard. In the future, I do have a couple more problems down here that for you to practice. You can kind of practice your skills. I'm going to do one more before I sign off. So I'm going to write this. So for number 5, I'm going to take that 32 as just a constant multiplier, x squared minus 4x plus 20. And I'm going to rewrite that fraction, so I'm going to complete the square. So if I were to say 32 times the integral of 1 over x squared minus 4x. Now if I divide that by 2 and square it, my perfect square trinomial would be plus 4, which means I'm going to have an extra 16 on the outside because I broke that 20 apart into 4 and 16. So now I can say I have 32 times the integral of 1 over x minus 2 squared plus 16. Sorry, that 16 should be in the bottom. Okay. And I'm going to do a u substitution. So I have u equals x minus 2, du equals a 1 dx, or in this case, du equals dx. So I can write this as now a 32 times the integral of 1 over u squared plus 16. Okay, now this is one of those special cases for inverse trig. So I want to kind of show this and take your time, pause, rewind if needed. Okay, so when I do this, I'm going to rewrite this. I'm going to take a 16 out front. Okay, and what that's going to give me, if I factor out a 16, that's going to be a u squared over 16 plus 1 du. And I can now take that coefficient out front. If I take out a 1 over 16, if I take that 16 out of the denominator, that's going to give me now a 2 out front of 1 over u squared over 16 plus 1 du. And I'm going to rewrite that to be a 2 times the integral of 1 over u over 4 squared plus 1 du. Sorry, I'm getting a little messy here. And then last but not least, you have to do a second u substitution. I'm going to make it w is going to be that u over 4. So then dw would be a 1/4 du. And then I would get a 4 dw equals du. So I'm going to go way to the left because that's the only place I have room right now. So my integral is going to be 2 times the integral of 1 over w squared plus 1. And instead of du, I'm going to have a 4 dw. So I get an 8 tangent inverse of w, which w was u over 4, and u was an x minus 2 over 4 plus c. So that would be my antiderivative. Okay, so a lot going on there. Number 5 obviously has a lot of moving pieces. Kind of go from there. All right, so again, there's some more practice. I posted the answers to these practice so that way you can see them. Hopefully this helped, and I will see you guys in just a little bit.